Welcome to the deep dive. We're diving into Elasticsearch today.
Oh, yeah.
We've got a great document here called Elasticsearch Expertise and Niche Topics.
Lots to unpack there.
For sure.
Hmm.
Whether you're prepping for a meeting or just curious about Elasticsearch, this is your crash course.
It's become so fundamental, for anyone working with data. It's
Absolutely.
open source and can handle anything from searching websites to like real-time security logs. It's incredible.
Okay, so powerful stuff. But for those totally new to this, what is Elasticsearch at its core?
At its heart, it's a search and analytics engine, but distributed.
Okay.
Think of it like a library, but huge. And instead of books, it's data.
Makes sense.
Text, logs, sensor readings, anything, and Elasticsearch helps you store it, search it, analyze it, all super fast and efficient.
So like a search engine on steroids, but for any data, not just web pages.
Exactly. And that distributed part is key, means it can spread the workload.
Oh, okay.
Across multiple servers, we call them nodes, so it can handle massive amounts of data and traffic.
Nodes, you mentioned those. What are they exactly and how do they fit in?
So each node is like a librarian in our data library. They
Hmm.
each manage a section. Those are called indexes.
Right.
And indexes are divided further into shards, like bookshelves. That way, if one librarian's busy, others can help, keeps things running smoothly.
Gotcha. So nodes working together, managing data across indexes and shards. But how does that data get into Elasticsearch?
That's where indexing comes in. It's adding the new books to our library.
Okay.
Usually we use JSON. It's a way to structure data.
Of a label tells the librarians where to put each book.
Exactly. Your document has that example with lecture notes.
Yeah, it shows adding a document, user date, message, and boom, searchable.
Right. It's so easy to get data in. And once it's there, the real fun begins with searching and retrieving it.
But I'm guessing simple searches aren't always enough. What if I need lecture notes on Elasticsearch and data visualization? Or notes from a specific user?
That's when Elasticsearch's advanced querying comes in. You can use Boolean operators like ND or not to combine terms, like saying, find me books on astronomy ND published in the last 5 years.
Wow, so super precise filtering for your data.
Yes. And it goes even deeper. For more complex stuff like finding books about the same character across different series, we have nested and joined queries, those search across different data sets, connecting info.
Sounds powerful, but I'm a bit intimidated by all these queries.
Don't worry, Elasticsearch has an intuitive query language and a RESTful API. Easy to use from different programming languages and tools.
Okay, that's good to hear. So we've got getting data in, searching it, combining search terms, but that's just scratching the surface, right? What about data analysis?
You're right, searching is just the start. Elasticsearch also has aggregations.
Okay, aggregations. Tell me more. This sounds interesting.
So imagine you want to understand the trends in your data. Not just finding specific info, but analyzing the whole thing. Aggregations let you calculate averages, find the most frequent terms, group data by criteria.
So instead of finding one book, we're analyzing the whole library.
Yeah.
Like the most popular genre, average book length, authors with the most books.
Exactly. It's like your librarians analyzing the whole collection, giving you summaries.
Love that analogy. Can you give some specific examples of how these aggregations work?
Sure. One is terms aggregation, finds the most frequent terms like popular keywords. Then there's date histogram aggregation, groups data by time. You could track, say, book borrowing trends throughout the year.
So it reveals hidden patterns, like a data detective. This is incredible stuff. But with all this data and analysis, how do we make sure Elasticsearch runs smoothly?
That's where performance tuning comes in, like a well-maintained library. Elasticsearch needs optimization to handle the demands.
Making sure books are shelved right, librarians trained,
Check.
out streamlined.
Exactly. In Elasticsearch, it's about index settings and query optimization. Index settings are like organizing the library's catalog. Defining data types precisely makes searching faster.
And query optimization is like training those librarians for speed.
Precisely. Using filters to narrow searches, avoiding unnecessary work, caching frequently accessed data. It's all about making Elasticsearch handle the workload, even as data grows.
This makes me think about security. This vast library of data needs protection, right?
You're absolutely right. Security is paramount. Just like a library protects its assets, Elasticsearch has robust features.
Security cameras, alarms, controlled access points, all that.
Exactly. Elasticsearch uses XPack for authentication and authorization, like library cards and access levels for users.
So not everyone can check out everything.
Right, some have access to rare books, others just the general reading area. XPack lets you define roles, who can access what data, what they can do.
But security goes beyond just access. We need to protect the data itself.
That's where encryption comes in. Elasticsearch uses TLS and HTTPS. It's like encoding the books themselves. Even if stolen, you can't read them without the key.
Gotcha. So a secure and well-organized library with Elasticsearch. But what happens as it grows? More books than shelves, more patrons than librarians.
You're thinking about scaling and clustering, like a library expanding or opening branches. Elasticsearch needs to scale for growing data and traffic.
Makes sense.
There's vertical scaling, like giving librarians better computers.
All right.
And horizontal scaling, adding more nodes to the cluster, distributing the work.
Like opening new library branches.
Yes, each with its own resources. And then there's cluster management, how Elasticsearch keeps things running smoothly as the cluster changes. Remember those shards? Well, Elasticsearch makes replica shards, backup copies.
Like backup books in case something happens to the originals.
Exactly. If a node goes down, replicas take over, no data loss. It also handles rebalancing data as nodes are added or removed.
So it's all about maintaining a healthy, resilient data structure as things change.
Precisely.
Impressive stuff. We've covered so much, from basics to scaling and security. But Elasticsearch doesn't exist alone, right? There's a whole ecosystem around it.
Absolutely. It's like the heart of a data ecosystem. Integrating seamlessly with tools that enhance its capabilities make it versatile.
Two that come to mind are Kibana and Beats. Kibana's like the library's analytics department, seeing how patrons use it.
Exactly. It's a visualization tool, creating dashboards and charts from your Elasticsearch data.
So understanding trends, seeing the big picture.
Yes. And Beats, those are like couriers delivering new books to the library. FileBeat for log files, MetricBeat for system metrics, and more.
Keeping the library running smoothly. Okay, so this powerful engine integrates with other tools to manage data. But where does Elasticsearch really shine? Give us some real-world examples.
There are three key areas: log analysis, full-text search, and real-time analytics.
Okay, let's hear them.
Log analysis is like analyzing security logs in our library, tracking anything suspicious.
Like a detective looking for clues.
Exactly. Then full-text search, imagine a huge digital library catalog. Elasticsearch can handle that, searching by keywords, titles, anything.
Like a superpowered search bar.
Precisely. And finally, real-time analytics. Imagine tracking book borrowing trends as they happen.
Wow, amazing.
So you can identify popular titles instantly and adjust inventory. That's the power of Elasticsearch in real time.
Incredible stuff. But for our listeners who want to become experts, what are some niche topics that take things to the next level?
Great question. Three stand out: machine learning, custom plugins, and monitoring and alerting systems.
Ooh, sounds advanced.
If you want to master Elasticsearch, these are key.
Okay, break it down for us.
So machine learning, it's like having a system that predicts which books will be popular. Elasticsearch has a dedicated module for this, including anomaly detection.
Like a librarian who can predict future trends.
Exactly. Then custom plugins, those extend Elasticsearch's functionality. Imagine plugins for interlibrary loans or managing rare book collections.
So tailoring it to specific needs.
Yes. And finally, monitoring and alerting systems, those keep an eye on things. Elasticsearch monitoring tracks metrics like CPU usage, cluster health.
Like a checkup for the library's infrastructure?
Yeah, exactly. And Watcher triggers alerts for specific events, like a node going down. It's all about keeping your Elasticsearch cluster healthy and secure.
Wow, we've covered so much in this first part of our deep dive. From the basics to these advanced ideas, we've seen how Elasticsearch fits into the world of data.
And we're just getting started.
Welcome back to the deep dive. In part one, we laid the groundwork, those building blocks of Elasticsearch.
Nodes, indexes, shards, queries, we covered it all.
We did, and even touched on security and scaling. Now I'm ready to get practical. How do we use and manage Elasticsearch effectively?
Well, one of the first things is deciding how many shards and replicas you need.
Okay, shards. We talked about those, but remind me, what's their role?
They're how Elasticsearch stores data across multiple nodes, the basic unit, like individual volumes in an encyclopedia.
Right, and replicas are the backup copies for redundancy.
Exactly. If one shard goes down, a replica takes over, data's still there.
Like backup encyclopedia volumes, in case one's lost.
But how do you decide how many of each to create? No magic formula, unfortunately. It depends on your data size, performance needs, resources.
So a balancing act. Too few limits you, too many is inefficient.
Right. Finding the sweet spot is key for both performance and resource use.
Okay, shards and replicas, check. What else is important for Elasticsearch success?
Optimizing your mappings. Those define how data is stored and indexed. Think of them as blueprints, telling Elasticsearch how to organize each piece of info.
Like a cataloging system for our encyclopedia, making searching easier.
Precisely. Specifying field types, analyzers, all those parameters matter for performance.
Makes sense. Anything else at this stage?
Don't forget backups, crucial to prevent data loss. Imagine a fire destroying all your encyclopedias. That's what we're avoiding.
A nightmare scenario. So backups are our insurance policy. Best practices for Elasticsearch backups.
Elasticsearch has snapshots for consistent backups, or you can use third-party tools, cloud services, for disaster recovery.
Okay, data's backed up. What about security? We touched on it, but it's so important.
Absolutely paramount in any real-world setup. Robust authentication, authorization, encryption, both in transit and at rest, and granular security policies, controlling access to protect your info.
Like a multi-layered security system for our library.
Exactly. Authorized users only, and protection from unwanted changes or deletions.
Gotcha, security covered. Now, what about when our data explodes in size? Scaling, we talked about it, but any specific strategies for big data in Elasticsearch?
That's where things get fun. Elasticsearch has a lot of tools for this. One is Logstash, a data processing pipeline.
Okay.
It can ingest, transform, enrich data before it goes to Elasticsearch.
So Logstash takes raw data, cleans it up, formats it, preps it for indexing.
Exactly. Parsing log files, extracting fields, enriching with external info.
Powerful stuff. But what about managing the indices themselves with huge data?
There's Index Lifecycle Management, or ILM for short. Automates index management based on data age and usage.
So like archiving old encyclopedias or moving lesser used ones.
Yes. You define policies to move data to cheaper storage, or even delete it when no longer needed.
So you're only storing what's necessary, optimizing resources.
Right. And for truly massive data sets, there's the hot worm architecture. Distributing data based on how often it's accessed.
So the new releases versus the archives, different storage tiers.
Exactly. Hot nodes for fast access to frequently used data, warm nodes for the rest, optimizing both performance and cost for big data.
I'm seeing how Elasticsearch handles these challenges. But let's shift gears back to those niche topics: machine learning, custom plugins, monitoring. Starting with machine learning, remind me about that Elasticsearch ML module.
It's like having data scientists analyzing your data, finding hidden patterns.
Powerful, but machine learning can be intimidating. Can you give concrete examples in the context of Elasticsearch?
Sure. Anomaly detection, like monitoring our library's security logs. The ML module can spot unusual patterns, potential breaches.
Like a security guard trained to see what we might miss.
Exactly. Or forecasting, predicting future trends based on past data, like predicting book demand or infrastructure bottlenecks.
Adding a layer of intelligence to Elasticsearch. What about custom plugins? Real-world examples of extending Elasticsearch's functionality.
Custom plugins tailor Elasticsearch to your needs, adding features, integrations, modifications, like engineers building tools for your specific library.
Concrete examples.
A plugin handling interlibrary loans, or one managing rare book collections. Lots of possibilities.
So much potential for customization. And finally, those monitoring and alerting systems. Elasticsearch Monitoring and Watcher remind us how they work, why they're crucial.
They're like the eyes and ears of your cluster, always watching for problems. Monitoring is like inspectors checking the library, making sure everything's working, tracking CPU, memory, disk space, search performance, all those vital signs.
The dashboard for your cluster's health.
Exactly. And Watcher, that's your alert system, notifying you of anything suspicious. You set rules like a node failing or search latency spiking, even unusual access attempts.
Like a security guard for your data.
Precisely. These systems maintain health, performance, security, proactive problem solving, keeping data safe and accessible.
We've covered a lot, again, in this best practices, big data, those niche topics. I'm starting to grasp the full potential of Elasticsearch.
We're getting there.
Welcome back to the deep dive. We've explored how Elasticsearch works, the nuts and bolts.
And the practical side, managing it all, handling those huge data sets.
We even touched on those cool niche areas, machine learning, custom plugins, all that. Now I want to see in action real-world use cases where Elasticsearch is making a difference.
It's being used everywhere, e-commerce, cybersecurity, healthcare, research. Its ability to handle big data, complex searches, real-time insights. It's a game changer.
Okay, lots to cover. Let's start with something everyone gets, e-commerce. How's Elasticsearch changing online shopping?
Think about browsing a huge online store, millions of products. You need to find what you want fast. That's Elasticsearch.
Powering the search bar, letting you search by anything?
Exactly, but it goes deeper. Autocomplete, fuzzy matching for typos, even personalized recommendations.
Like a shopping assistant who knows your style.
Yes, and it helps the business too. Analyzing customer behavior, tracking inventory, fraud detection, even personalizing marketing. It's a complete solution.
Wow, a command center for e-commerce. That's impressive. Okay, let's switch gears. Cybersecurity. Security is everything these days. I can see how Elasticsearch helps, but how exactly?
One big one is SIME, Security Information and Event Management. It analyzes tons of security logs, from firewalls, intrusion systems, antivirus, everything.
Like a 247 security guard.
Right. Elasticsearch spots, patterns, anomalies, anything unusual that could be an attack. Alerts security teams immediately.
And it helps them respond too, right?
Absolutely. Visualizing data, creating timelines, even automating responses to certain threats.
Like a security nerve center coordinating everything. Powerful stuff. Okay, let's jump to something completely different, healthcare.
Healthcare is seeing huge benefits from Elasticsearch, too.
I bet. What are they using it for?
And medical imaging is a big one. Imagine indexing and searching X-rays, CT scans, MRIs.
So doctors can find what they need instantly instead of digging through files.
Exactly. Saves time. Crucial for diagnosis and treatment, especially in emergencies.
That's incredible, saving lives with Elasticsearch. Any other healthcare uses?
Oh yeah, analyzing patient records, tracking disease trends, even personalizing treatment plans.
Like a superpowered medical librarian supporting those crucial decisions.
Mm.
Okay, last but not least, scientific research. Elasticsearch seems to be everywhere. What are scientists doing with it?
All sorts of things. Astronomy, environmental science, you name it. Astronomers use it to analyze telescope data, looking for new objects, patterns.
Sifting through all that data to find those breakthroughs.
Exactly. Environmental scientists monitor pollution, track climate change, analyze sensor data, understanding our planet better.
Wow. And what else?
Particle physics, analyzing data from accelerators, genomics research, so much more.
Mind-blowing how Elasticsearch contributes to these discoveries. This has been an amazing journey, exploring Elasticsearch from top to bottom.
It's been great sharing this with you.
I've learned so much. It's clear Elasticsearch is changing the world.
And it's only getting started. The future of data is exciting.
That's a perfect way to wrap things up. Thanks for joining us on this deep dive into Elasticsearch. Keep exploring, keep learning. The possibilities are endless. Happy searching, everyone.